Right. During the previous session, we talked about the loan amortization. We said that amortizing a loan means reimbursing a loan. We saw how to construct the amortization schedule regardless to the modality of reimbursement. From this amortization schedule, we derived different formulas here. Then we said that according to the reimbursement modality, in addition to these formulas, we can derive other formulas that will facilitate the calculation for us. The first modality of reimbursement, we said, is when the loan is reimbursed through constant payment. So this column, all the payments in this column are the same, are constant. In this case, to compute the constant payment, we use this formula. To compute, for example, to see the link between the amount borrowed and the first principal portion, we use this formula. This is the link between the principal portions, and this is how to compute the amount of the loan not yet reimbursed at any date k we want. And we do an application for this. The second modality of reimbursement is when the principal portions are constant. So when the principal portions are constant, knowing that the interest is always computed as follows: the interest rate times the amount of the loan not yet reimbursed at the beginning of each period. And since the amount of the loan not yet reimbursed will decrease over time because each period we reimbursed a portion from it, principal portion constant and the interest is decreasing, it means that the payment will decrease too. So payments and interests are not constant, they decrease over time. The only constant thing here is the principal portion. In this case, how to compute the principal portion is simpler than the case of reimbursement through constant payment, since all the principal portions must equal the original principal portion or the original principal borrowed. It means that P, the principal portion, the periodic principal portion, could be annual, monthly, etc. Each principal portion is simply the amount borrowed over the number of payments that we will make, the number of principal portions that we will reimburse. Simply P is equal to L0 over N. Now, we know that this is the relationship between two consecutive payments, two consecutive principal portions. This is the general formula regardless of the modality of reimbursement. When we take the case of constant principal portions, principal P plus 1 is equal to principal P. We can replace both by P, which is the same. P minus P times 1 plus I will give you P minus P minus IP. P minus P will give you 0. So payment P plus 1 minus payment P will be minus I times P. This is to say that the payment P plus 1 is less than the payment P because the difference is negative. It means that the payment will decrease, as I explained. Since interests will decrease over time, principal portions are constant, principal plus interest will decrease over time. Now, let's do an example to better understand this and to see the difference between this case and the case when we reimburse the loan through constant payments. We are asked to construct the amortization schedule for $1,000 when the interest rate is 10% and the reimbursement through constant principal over 3 years. The reimbursements are annual in this case, the basic case. So here, the first thing to do, like in the case of reimbursement through constant payment, we start by computing the constant payment. Here, since the reimbursement is through constant principal, we start by computing the constant principal. So constant principal is L0 over 3 annual constant principals, 333.33. So in our table here, we put the amount initially borrowed, 1,000, and we put the constant principal. We start our table by the constant amount, 333.33. Just here I rounded the third payment, the last payment, to 333.34 to get the sum of the principal portions equal to the initial amount borrowed. To compute the interest is the same thing. Always the interest is the balance at the beginning times the interest rate. Here the payments are annual, so the interest will be annual. We need annual interest rate times the amount not yet reimbursed at the beginning of the year. 10% times 1000 will give you 100. The sum of the principal and the interest will give you the payment of the first year. Balance at the beginning minus principal 1 will give you balance at the end of the first year. This is the balance at the beginning of the second year. Multiplied by I will give you the interest 2. Plus principal 2 will give you payment 2. Big balance beginning of year 2 minus principal 2 will give you balance at the end of year 2, which is the balance at the beginning of year 3. Multiplied by 10%, I will give you the last interest. Sum of the last interest and the last principal portion will give you the last payment. And balance at the beginning of the third year minus the third principal portion are equal. The difference between the two will give you 0 to say that the loan is fully reimbursed, fully amortized. You notice here that interests and payments decrease over time. So, and this confirms the formula here. Two consecutive payments, between two consecutive payments is needed. Modality of reimbursement. So we examined the case of constant payment, constant principal. The last modality that we will cover in our chapter is constant interest. To get constant interest and to keep this formula unchanged, because we said that always the interest is computed by multiplying the interest rate by the balance, the amount of the loan not yet reimbursed at the beginning of each year. So to get a constant interest here, since I is constant, the amount of the loan not yet reimbursed at the beginning of each period must be constant. So L1, L0, Ln minus 2, Ln minus 1 should be constant. To get a constant balance at the beginning of each period, we should have 0 principal portions. So P1, P2 until Pn minus 1 must be 0 to get a constant interest. When it means that each year each period from 1 until n minus 1, the principal portion reimbursed is 0. This means that each period we will reimburse only the interest. This is why when we have a reimbursement through constant interest is also called, this modality of reimbursement is also called the interest-only loan. Interest-only loan means that each year or each period we reimburse only the constant interest computed on the basis of the borrowed amount, which is I times the amount borrowed times L0. We don't reimburse any principal portion, and the amount borrowed is reimbursed in its totality only at the last date, last year, last period, in the last principal portion. So the constant interest is I times L0, as we said. Principal from 1 until n minus 1 is 0, and the last principal portion is equal to L0. Of course, the payment is always the same, principal plus interest, regardless to the modality of reimbursement. Let's do this application to better understand the difference between the three modalities of reimbursement. We are asked to construct an amortization schedule for $1,000 with 10% interest rate. reimbursement through constant interest over 3 years. So the first thing to do is to compute the constant amount. The constant amount here is the interest. So interest times the amount borrowed, 100. Each year we have 100 as constant interest, and this is the balance at the beginning of the first year. As I said, from 1 until n minus 1, until 3 minus 1, until 2, the principal portion must be 0. To get 1000 minus 0, 1000. This is the balance at the beginning of the second year. 1000 minus 0, 1000. This is the balance at the end of the beginning of the third year, to get the same interest here. And the amount borrowed is reimbursed in its totality at the last date in the principal portion of the last date. The payment is always interest plus principal, 100, 100, 100 plus 1000. 1000 minus 1000 will give you 0. The loan is fully amortized. This is the last modality of reimbursement. Now, the question is, what is the best alternative for us? For us, borrowing $1,000 at 10% cost interest rate and reimbursing 100, 100, 100, 1,100, or reimbursing in the case of constant principal 433.33, 399.99, 366.67, or reimbursing 402.11, 402.11, 402.11 is the same thing. These $1,000 will cost to us the same thing, because the present value of all these payments will equal 1,000. So if we are asked to compare 402.11, 402.11, 402.11 after 1 year, 2 years, 3 years, their present value today will give you 1,000. Present value of 433.33, 399.99, 366.67 today, their present value is 1,000. The same thing for 100, 100, and 1,100. Present value is 1,000. So the cost for us is the same because the interest rate is the same. But according to the availability of funds, of cash for the company will choose the first, the second, or the third modality of reimbursement according to the availability of cash. If the money I borrowed is used in a project, and we will talk later in the chapter 2 about the capital budgeting, the investment decision, when the money borrowed is used for a project, and this project will generate cash for us only in the last years. So for first years, we will not we will not have a return, we will not generate, the project will not generate cash for us. So it is better to postpone the reimbursement. But we reimburse only the interest for first years, and we reimburse the totality of the amount in the third year. If the money is used for a project that will generate decreasing cash flows, so the first year we will have a high return, high cash flow, then these cash flows will decrease over time. We can use the second alternative. Or we can use the first one if we are indifferent. We want to pay the same amount each year, but the cost of the three modalities of reimbursement is the same. I hope it is clear. We have another modality of reimbursing a loan. We call it the pure discount loan. The pure discount loan is very simple. Simply, the borrower will set with you the interest rate, for example here 10%. He will give you an amount today, knowing that you have to reimburse him in the maturity, at the maturity date, for example, at the end of year 3, 1,000, the principal, the totality of the principal 1,000 is reimbursed at the end of the third year. But you will not pay any interest or any other payment during the first, the second year. You have to pay only one amount at the last date, which is the date 3. So here the lender will subtract from the amount he'll accept to pay you today the interests. So what will he subtract today? What will he keep today? He will keep simply the interest that the interest corresponding to the $1,000. So simply, if you will pay 3 years from now 1,000, if the interest rate is 10%, what this lender will accept to get from you today that replaces 1,000 3 years from now, we said that this in the introduction of the chapter is simply the present value of 1,000 using 10% as discount rate. So if you take, for example, $1,000, 1,000 over 1 plus I power 3 will give you 1,000 over 1.1 power 3 will give you 751. 751 is the amount that you will receive from the lender today. And you have to pay him at the maturity date, at the date 3, $1,000. We call this modality of reimbursement, well, of loan, a pure discount loan. Pure discount loan, because simply the value today that you will receive is the discount value of what you will pay in the future. Only one amount received today, 751. Only one amount paid in the future, 1,000. We will see this, we will review this in the chapter concerning the bonds. Okay? The third, I guess, or the fourth chapter. Is it clear?
مسيو هذه بارتي الأخيرانية ما فهمتش بكدا، متاش كان تعاودها لي من فضلك.
باه إذا أنت I will pay you 3 years from now $1,000. أنا I will pay you $1,000 3 years from now, knowing that the interest rate is 10% in the economy. What will you accept today to get from me that replaces 1,000 3 years from now? شو تقبل اليوم من عندك؟ تقول لي اعطيني 1,000 of course لا. تقول لي راهو يكفيني تعطيني present value تاع 1,000 هكا ولا؟ انا كي نعطيك انا اليوم 751 اللي هي present value تاع 1,000. 751 لو كانت تحطها انت ب 10% لمده 3 سنين تجيب لك 1,000 3 years from now. So 1,000 3 years from now is equivalent to 751 today. دونك تنجم انت تقول لي I will give you today 751 هذا باش نتسلفوا اليوم البنك. 3 years from now نعطيها 1,000. هذا هي اللون، كأنه قصت لي الانترست بالمسبق، خذيت الانترست خليته معرضه، اعطتني جاست 751 اللي هو present value تاع 1,000 3 years from now. فهمت ولا؟
اي مسيو فهمت. معناتها جوست ناخذوا الفاليو اللي باش نتسالفوها ونعملوها ديسكاونتينغ قداش، معناتها باش نحسبوا البريزنت فاليو.
صحيح، هذاك علاش اسمها اسمه بيور ديسكاونت لون. اوكي
مسيو
يس.
أنا في الكا هذا في عظمى أنت تختار البيجينينج بالانس والبنكة باش تختار قديش تدفع في الآخر بالكل. أنت تختار قديش تدفع وهي تعطيك الفلوس اللي باش تاخذها.
فوالا أنت تختار قديش باش أنت تعرف روحك قديش باش ترجع في الفيوتشر ولا قديش حاجتك اليوم. تحسب أنت قديش حاجتك اليوم باش تتسلف، تحسب لك هي الفيوتشر فاليو نتاعهم بعد 10 سنين ولا 3 سنين ولا هو، تقول لك راك باش ترجع لي بعد 10 سنين the future value what I give you today according to this quoted interest rate. Okay?
Okay.
The simplest way of getting a loan. هذا in general الجفرمنت هما اللي يتسلفوا بالفلوس كيما هكا، يتسلفوا فلوس على 20 سنه ولا على قداش. يقول لك هاي باش ما نقعدش نعمل في بايمنتس في الانترميديري بايمنتس، نتسلف فلوس مره واحده ونرجعها مره واحده، يسموه ذا بيور ديسكاونت لون، واللي هما الجنرال بوندز هذوما تو نحكيو عليهم ان شاء الله في الشابتر نتاع البوندز. في عندهم الفيتشر.
مسيو
يس يس
مسيو في لي بنك معناها العباد العاديين قاعدين معناها غيرمون تصير الحكايه هذه، نجم عبد معناها توف عبد
لا لا في اللي بانك ثم المورجج اللي قاعدين نحكيو عليه واللي حكينا عليه بكري، وهاو تنزيدوا ناخذ سي عملنا وكملنا. تتسلف فلوس وتعمل constant payments in general، هذا اللي قاعد يصير constant payments، هذا اللي يصير in general 90% من اللونز هاك. اوكي
اوكي ثانك يو.
ولا يا جماعه؟
Sir, I have a question. You've mentioned that there is no difference between the three different cases because they have the same exact present value, but there is a difference in the total amount of the payments and the same amount of time, the period of time, 3 years. Doesn't that have an effect or something like that?
كيفاش عملت السام انت كيما هكا؟ خذيت sum of the payments، خذيت sum of the payments، خذيت sum of the payments، but effectively can we make the sum of different payments that occur at different dates?
No.
دونك بالبيتس او انا اكسبري عملت التوتال هذايا وسالتهم نقول لهم اما خير يمشي اللي يلقى التوتال اقل، معناها كانوا $1 1 year from now هو $1 3 years from now هو $2 years from now. That is not correct. أول principle في time value of money we can't make the sum or the difference of different amounts that occurs at different dates. لازم كل ترجعهم الديت واحده وبعد اعمل السام، رجعهم الكل البريزنت واعمل السام باش تلقاهم الكلهم 1000. هذاك اللي ورينا الكوست نتاعهم از ذا سيم.
اوكي كلير.
بس معناها التوتالز هذوكم الكل غالطين.
شنو؟
التوتالز هذوكم الكل غالطين خاطر نجمعوا في $، مش في نفس العام.
همش غالطين، ماثيماتيكلي صحيح but economically
لا نحكي بالتايم فاليو.
لا بالتايم فاليو ما نعملوش توتال هكا، بالتايم فاليو نعملوا بريزنت فاليو ونعملوا السام. اوكي كيما قرينا كيما شوفنا في الاكزامبلز اللي فاتوا الكل، عملنا اكزامبلز فيهم حكايات كيما هكا. مش هذا غلط، هذا التوتال نتاعهم كيما هما، اما we can't base our decision على التوتال هذا. فهمتوا ولا؟
يس
حاجه اخرى يا جماعه في الكالكوليشن ناو في الاكزامبلز اللي كيما ديجا عملنا اكزامبل عليه وتو تشوفوا زاده في التوتوريال. الانترست always the calculation تاعهم the same، هو الانترست rate times the balance at the beginning of the year. Only the interest is annual because the payments are annual, so we keep 10% ونضربوها في balance at the beginning of the year. If the payments or reimbursement were monthly reimbursements, simply 10% نرد نقسم على 12، we divide it by 12 to get the monthly interest rate, and we do the calculation according to the monthly interest rate. You will get monthly payments, monthly principal portions, monthly interest. هذا حكينا فيه ديجا وتنجموا عندكم الاكزامبل هذايا. فور اكزامبل ها عندك هذايا خدمناه اكزامبل 33 فيه reimbursement of a loan through constant payments and the payments are monthly. So to compute the monthly payment we have to convert the interest rate into monthly rate bien sûr. والنمبر of payments إذا كان اللون على 25 years الان نتاعك الباور اللي عندك هوني number of payments that you will make هما 12 times 25 years هما 300 payments. We adapt n and we adapt I according to the periodicity of the payments. اوكي اوف كورس هذه حاجه لوجيك معناتها. طيب let's review all what we did in the chapter 1, 2 and 3. So the loan amortization, I think that it is clear مع quelques exercises اللي باش تعملوهم في التوتوريال ومع اللي شفناه تويكا نورمالمون سي بون. اجا نعملوا ريفيو على part 1, 2 and 3 to try to understand everything about these three parts. ركزوا معايا مليح هون. an important application اللي قلت لكم اخدموه في الدار باش تحاولوا تعرفوا التريكس والمشاكل وين. لا علينا. Example 34. Assume that it is now January 1st, 2021. On January 1st, 2022, you will deposit $2,000 into a savings account that pays 20% interest annually. If the bank compounds interest annually, so 12% are compounded annually, you will receive the totality of 12% once a year. How much will you have in your account on January 1st, 2027? So first thing to do is to draw a timeline, even for draft. Don't answer any question for the time value of money without drawing the timeline. جيت هوني صورت التايم انت. جيت هوني. Question A. Today is 1/1/2021. On 1/1/2022, we will deposit $2,000 at an interest rate of 12% compounded once a year. What is the accumulated amount on 1/1/2027? Simply, we will use future value n equal present value of the date t times 1 plus I power n minus t, future value of a lump sum. N minus t is the number of years of interest. From 22 to 27, we have 27 minus 22 years. We have 5 years of interest. Annual interest 12%, you'll get 3,524.68, the obtained amount 1/1/2027. Second question.
هنا نحكيو على lump sum.
Of course lump sum, ما دام عندك amount واحد.
Okay.
What would your January 1st, 2027 balance be if the bank used quarterly compounding rather than annual compounding? We will do the same thing, but the interest rate is not 12% compounded annually, it's now compounded quarterly. So we still have a lump sum, and we need to compute its future value after 5 years. Here we have, as we did before, two alternatives. We can either use the interest rate per period, per quarter, which is I quarterly, I nominal over 4, 3% each quarter. And we compound the $2,000 using these 3% each quarter during 5 years. So during 20 quarters, 5 years times 4 quarters per year, you'll get 20 period, 20 quarter of 3%. You'll get, واللي هي الفورمولا بتاعنا, future value and present value 0, 1 plus I nominal over m power m times n. Or we can keep the logic of annual interest rate. 12% compounded quarterly is equivalent to 12.55% once a year, which is the effective annual rate, the equivalent rate. There were 1 plus I nominal over 4 power 4 minus 1. You compute the annual interest rate compounded annually, then you compound the 2,000 using this annual rate compounded annually. During 5 years, we will have the same logic of the first question, but I here is 12.55. You'll get the same future one. Is it clear here?
Yes.
Yes.
The third question now. We will take the case of annuities now. Suppose you deposited 6 equal suppose you deposited the $2,000 in 4 equal amounts, 4 equal annual amounts of $500 each. The first amount on January 1st, 2022. How much will you have in your account on January 1st, 2027, based on 12% interest rate compounded annually? So here be careful. The interest rate is not annual interest rate, compounded annually. So we draw the timeline in which we put the first amount deposited on 1/1/2022, 500. We have four equal amounts. So the last one will occur on 1/1/2025, and the annual interest rate is 12%. What is the future value on 1/1/2027? Here we have three techniques. The basic one, which will take too much time, we will compound each amount separately as we did. We will take the answer A, and we will repeat it 4 times. So first 500 will be compounded at 12% during 1, 2, 3, 4, 5 years, power 5, plus 500 times 1 plus 12% power 4 years, plus 500 times 1 plus 12% power 3, and 500 times 1 plus 12% power 2. And you make the sum. You'll find 2,997.59. Or, to save time, to avoid many errors in the calculation, we will treat these deposits as an annuity. Now, which kind of annuity we will use here? Which formula will we use? As I said, this will depend on the future value I will select in my first step of calculation. Annuity. If the future value selected during the first step coincides is the future value of the last deposit, I want to compute their value at the date of the last deposit, which is the simplest thing to do. This will require from me the use of the future value of an ordinary annuity, which is A times 1 plus I power n minus 1 over I. What is A? A is 500. What is I? I is the interest rate that corresponds to the periodicity of the deposits. The deposits are annual. We need an interest rate compounded annually, or 12% is already compounded annually, so we will use 12%. The number of deposits is n, 4 deposits, power 4, minus 1 over I. This will allow me to compute the future value of these 4 deposits at the date 1/1/2025.
Sir, I have a question.
I'm asked, but I'm asked to compute the future value of these 4 deposits on 1/1/2027, not 25, and I computed their value for 25. To compute their value for 27, as I explained at the beginning of this chapter, of this session, we compound this amount for an additional 2 years. So 1 plus I times power 2. You'll get this. Now, from the perspective of 1/1/2026, if the selected future value in the first step is 1 period after 1 year after the date of the last deposit, this requires from me the use of the future value of an annuity due now. Much ordinary annuity. For an annuity due from a 1 plus I زائدة هون. Donc this times 1 plus I will give you the future value of the date 26. To compute the future value of the date 27, you need to compound this for an additional 1 year. You'll get the same result. As I explained, there's no questions in there.
C'est bon, monsieur. Juste حبيت نسأل اسكو هو في 2026 باش يعمل ديبوزيت معناها؟
ما وين باش يعمل؟ ما عنده حتى ديبوزيت، قال لك عملت 4 equal deposits، ما عاد تزيدوش من حاجات من عندكم.
احنا كي يبدا عندنا انويتي معناها ديما فما كونستنت ديبوزيت.
هما كونستنت ديبوزيت من 22 حتى ل 25.
معناها هو عمل 4 ديبوزيتس وأنا نحب نعرف قداش باش تخلط الفالور نتاع الديبوزيتس اللي عملهم في 2027.
هذه هي الكويستشن تاعنا. يس قلت لك يس. هذه هي الكويستشن تاعنا.
باهي.
هذا ايش قال لي هو؟ هذا واحد هذا ايش قال؟ Suppose you deposited 2,000 in 4 equal unknown amounts of 500 each starting from January 1st 2022. How much will you have في 2027؟ واضح يا فندم. هكا ولا يا جماعة؟
واضح يا شباب.
Yes, sir.
D now. Suppose you deposited now 6 equal unknown amounts. ما عادش 4 ولا 6 in your account starting from January 1st 2021. donc جينا هوني حطينا من 1/1/21 first amount. إذا كان عندي 6 donc the last amount will be deposited on 1/1/2026. 6 A's. The interest rate is annual interest rate compounded annually. هوني قال assuming an annual interest rate of 12%. Since I don't have compounded semi-annually, compounded quarterly, compounded monthly, we use the default rate اللي هو compounded annually. So interest rate is 12% compounded annually. How large should each of your deposits have to be for you to obtain the same ending balance as the one calculated in part A? Donc, for part A, for question A, the accumulated amount is 3,524.68. Donc, I need at the date 1/1/2027, 3,524.68. The future value of all these deposits must be 3,524.68. To be able to compute the A, the constant A, we need to set these A's in the formula of an annuity. We can determine A if we use future value of each A separately. A times 1 plus 12% power 6 plus A times 1 plus 12% power 5 plus A times 1 plus 12% power 4 until A times 1 plus I power 1 وتلوج على A. We can do this mathematically. So to be able to determine the constant A, we need the formula of the annuity. Okay? Now, will we use the formula of an ordinary annuity or the formula of an annuity due? To compute the future value of all these A's, as I said, as I explained in the previous question, to compute their future value, we need, if we set the future value date for step الأولاني is date of the first deposit, نكتبوهم future value of an ordinary annuity, donc A times 1 plus I power 6 because we have 6 deposits over I minus 1 over I. Then we need to compound the amount here for an additional 1 year نضربوهم في 1 plus 12%. وإلا من الأول نقول the future value date occurs 1 period after the date of the last deposit. So here we need to use the future value of an annuity due formula اللي هي هذه الزوز كيف كيف. Okay, here the number of deposits here is 6 and the interest rate must be 12 because the deposits are annual. We need annual rate compounded annually, which is the 12% that I given as information from the beginning. So the A will be 3,524.68 over this future value interest factor of the unknown. تلقاها 387.17. Is it clear?
Yes, sir.
E now. Suppose now that you will need $3,000 on January 1st, 2027. To help you reach your $3,000 goal, your parents offer to give you $500 on January 1st, 2023. So you will receive only one amount of $500 on January 1st, 2023. In addition to this gift, you will get a part-time job and make 12 additional deposits of equal amounts each 6 months, with first deposit on January 1st, 2021. If all this money, the gift from your parents and the 12 additional deposits you'll make, is deposited in a bank that pays 12% compounded semi-annually, twice per year. How large must each of the 12 deposits be to reach your goal to accumulate at 1/1/2027 $3,000? So we draw the timeline. As I said, this is the first step. This is our timeline: 1/1/2021, 1/1/2027. From July 1st, the first deposit. July 1st, 2021. It means 6 months from now. July 1st, 2021. One semester from now, you will put this first deposit, and you have 12 deposits. If you deposit 12 amounts, the last deposit will occur on 1/1/2027. Count the number of A's, you'll have 12 A's. Right. In addition to these 12 A's, you deposited 500, the gift from your parents, on 1/1/2023. You need to accumulate on 1/1/2027 $3,000. What must be each A to get $3,000 if the interest rate is 12% compounded semi-annually? So here, if the interest rate is compounded semi-annually, the future value of the 500 at the date 1/1/2027 is 500 times 1 plus 12% over 2 power 2, to say that you will get the half of 12% twice a year. During how many years? From 23 to 27, you have 27 minus 23 years. You have 4 years. 4 years, each year you will get 2 interest. It means you will get 8 times 6% interest. So 500 times 1 plus 6% power 8. From this date to this one, you get 1, 2, 3, 4, 5, 6, 7, 8 times 6%. This is the future value of the 500. Now, what is the future value of the 12 A's? The future value of the 12 A's, knowing that the future value date coincides with the date of the last amount deposited, which means that we should use future value of an ordinary annuity. And the future value of an ordinary annuity, we have A times 1 plus the interest rate power the number of A's minus 1 over I. The number of A's, N, is known, 12. Now the dilemma here is, what is the accurate interest rate to use in this formula? It's very important what I'm explaining here. Since the deposits are semi-annual, the periodicity is 6 months. The interest rate that we should use in the formula of the annuity must be the interest rate of 6 months. An interest rate that you receive each 6 months. So the interest rate that each A will receive each 6 months, since A are semi-annual, is the semi-annual rate. 12% compounded semi-annually is equivalent to get 6% each semester. So we need to put here 6%, not 12%. Okay? Back. Here simply A is equal 3,000 minus this over the future value interest factor of the annuity, you'll get the deposit 130.15. Is it clear, Yasmin?
Yes, sir. Yes, sir.
Alright. Let's do the last part. Assume now that you will need $4,000 on January 1st, 2027. You will get a part-time job and make 12 semi-annual equal deposits of $100 each, with first deposit on July 1st, 2021. To help you reach your $4,000 goal, your parents offer to give you 3 equal annual amounts now, instead of only one deposit of $500. Now the gift is 3 deposits and annual deposits starting from January 1st, 2023. If all this money is deposited in a bank that pays, be careful here, that pays 12% compounded quarterly. 12% compounded quarterly. How large must your parents' annual gift be to get $4,000 on 1/1/2027? So we need to draw our timeline. So we have here the first, the 12 semi-annual deposits you'll make of $100 each, starting from July 1st, 2021. In addition to these 12,100, you will receive a gift from your parent, 3 annual deposits amounts, starting from 1/1/2023. So the first one will occur on 1/1/2023, second one on 1/1/2024, third one 1/1/2025. The obtained amount on 1/1/2027 must be 4,000. So what will be the future value of all these amounts? How to compute? Here we have 2 annuities. 2 annuities. The first annuity, which is 12 times 100, and the second annuity is 3 times the gift. To compute the future value of these annuities, should we use the future value of an ordinary annuity, an annuity joke, الحكاية دي كالكل? For the last time, I will repeat it. For the first $100 annuity, since the future value date coincides with the date of the last 100, we use the future value of an ordinary annuity, A times 1 plus I power n minus 1 over I. The future value of the second annuity, the 3 gifts. First, we compute their value at the date of the last deposit, 1/1/2025, using the future value of an ordinary annuity. Number of deposits, 3 deposits. Then we compound the amount computed on 1/1/2025 for an additional 2 years, 1 plus another interest rate power 2. Now, what are the interest rates that we should use? This is the dilemma here. As I said, as I explained before, when you use the future value of an annuity or the present value of an annuity, the formula of an annuity, always n refers to the number of A's you'll have, and always the interest rate that you should use must be adjusted according to the periodicity of the A. If A is annual, in the formula you should use an annual interest rate compounded annually. If A is semi-annual, you should use an interest rate in the formula which is the interest rate of a semester. If A is quarterly deposit, you should use the quarterly interest rate. A is monthly. You should use a monthly interest rate. So here, since the gift is deposited annually, we should use an annual interest rate compounded annually. But the interest rate here given is compounded quarterly. We have to modify the 12% and compute an equivalent annual rate. 12% compounded quarterly is equivalent to 12.55%, 1 plus 12 over m power m minus 1 over 4 power 4 minus 1. So the interest rate for the gift must be an effective annual rate compounded annually. We have 3 gifts. Now, for the 100 is semi-annual deposit, but the interest rate is compounded quarterly. Can we use 12%? No, it's not correct. Can we use 12.55% annual rate? It's not correct. The interest rate for each semester is not the 12% over 2. It's not 12% over 2. 12% over 2 is the semi-annual rate if 12% is compounded semi-annually, but 12% is compounded quarterly here. What is the semi-annual rate? Equivalent to a quarterly rate of 3%. Here the quarterly rate is 12 over 4, 3%. What is the semi-annual rate? Equivalent to 3% each quarter. هو 3% on a previous 3%. 3 على 3 compounded 2 times. هذا عملناه بكري. 1 plus semi-annual squared must be equal to 1 plus quarterly power 4. يعطيك semi-annual rate equal to 1 plus 3% power 2 كأنه 3% مرتين باش تاخذها minus 1 اللي هي 6.09%. 0.9% هي 3 على 3. 3% على 3% زي. So each semester the 100 will earn 3 على 3 أخرى. Donc it will earn 6.09%. How many A's we have? 12 A's. You'll get the future value of these two annuities. This is the only way of computing the gift. ما تنجمش هون الجفت تكتبوا gift times 1 plus 12.55 power 1 2 3 4 plus gift times 1 plus 12.55% power 3 plus gift times 1 plus 12.55% power 2 وتلوج على الجفت خاطر موجود مرة ما نضربوه في I power 3 مرة 4 مرة 2. Look, we need the formula of the annuity to be able to determine the gift. The gift, annual gift, 536.2. I hope it is clear, Yasmin.
Yes, sir.
So, هذا time value of money. هذا how to convert the rates, how to if you want. لمينا all the pieces اللي شفناهم في الشابتر بتاعنا الكل في الاكسرسايز هذايا. كيفاش نحسبوا periodic rate, how to use the equivalence relation, how to use the future value of an annuity if the interest rate is compounded more than one time each year. شفنا كل شيء هون. Normalement time value of money هذايا صعيب. فهمناه واحد خاطر now in this واحد remaining chapters in finance we will use these techniques to measure, if you want, the profitability or the net present value of a project, to say that the project is acceptable or not, to estimate the value of a bond, to estimate the value of a stock, an equity, etc. So we need to master this calculation, these techniques of computing future value, present value, and I hope it is clear. Do you have questions before taking a break of 5 to 10 minutes? Then we will start the chapter 2 capital budget.